Hi, so welcome to the first probability question video. For this question 10, we're given that these four gentlemen, I'm assuming, and 6 other athletes, so 10 athletes in total, take part in a 100-meter race. Each athlete will be allocated one lane, and the athlete's track has 10 lanes. Okay, so how many different ways can all the athletes be allocated? It's just going to be 10 different ways, which means it's 10 to the factorial. I think that's what it's called. I can't remember. Yeah, so that's going to be like 3, 6, 2, 8, 8, 0, 0. Cool. 4 athletes taking part in the event. Oh, sorry, I'm on this question. 4 athletes taking part in the event insist on being placed in lanes next to each other. In how many different ways can the lanes be allocated to the athletes now? Okay, so one thing I want to highlight is in the first example, okay, let's say you have athlete 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you basically got 10 groups with one person in each group. Okay, and so your counting principle is essentially then how many groups do you have to the like factorial. So 10 groups, so 10 to the factorial. Okay, so that's situation 1. Now in situation 2, what you actually have is 4 athletes insist on being placed next to each other. Okay, so if we were to put this into a hypothetical over here, so these 4 athletes could therefore be maybe in these 4 lanes. Okay, and then the rest of the athletes would be in the remaining lanes. Okay, so all of a sudden, you can almost treat this group, these 4 athletes, as one group. Like that's actually what you should do. So you've now essentially got 1, 2, 3, 4, 5, 6, 7. Okay, so you only have 7 groups now. Okay, so 7 groups is 7 to the factorial. Okay, but this doesn't actually give us the total different ways that these lanes can be allocated. Because inside of this group of 4, they can be arranged 1, 2, 3, 4, or they could be arranged 4, 3, 1, 2, or however many ways, okay? And how many ways is it? Well, essentially in this big group of 4, you've got 4 smaller groups, which is this 1, 2, 3, 4 smaller groups. And so that's why we do this. 7 factorial times 4 factorial, okay? And that is going to give you an answer of, let's see here, is equal to 1, 2, oh my, okay. That was not necessary. I don't know where that came from. 120,960. Okay. Then for your third and final question, it says if lanes are randomly allocated to athletes, determine the probability that Ben will be placed in lane 1, lane 3, lane 5, lane 7. Okay. This is our final situation here. I'll do it in red. Okay. So yeah, this situation. Okay, so in lane 1, we have Ben. Then in lane 3, Nkangla. Then in lane 5, Owen. Then in lane 7, Derek. Okay, so those are all fixed. Okay, there's no changing that. So we can almost just remove them from the equation. Okay, you don't need to worry about them. So where people can actually be allocated is in 1, 2, 3, 4, 5, 6 lanes. So now it's almost become a thing of there's only 6 lanes you can use technically. So think of it as if we say you have 10 lanes, how many different ways can you organize like athletes in those 10 lanes? Well, 10 to the factorial, which is what we got here. But now this question is essentially saying we can no longer use 4 lanes. Those people are predetermined, so they can't be changed. They can't be brought into the into the probability question. So now we technically only have 6 questions. So if I say to you, how many different ways can 6 lanes be organized? Okay, well, that's obviously 6 to the factorial. And so that's actually our answer. So for question 3, again, to be consistent, I'll do it in red. So it will be 6 factorial. That's the amount of different ways that this scenario can be organized. But the total, which we already worked out in question 1, is 10, right? So divide by 10 factorial. And that's going to give you 1 over 504 something, I think. Let me just pop that in my calculator. 40, okay, which is also equal to the decimal 0.000198 what. Okay, so yeah, I hope that helped. If you have any other questions, remember, pop them in the comments and then I'll answer them or make a video of them if it's a past paper question.